Hello, engineering aspirants. Now, as we discussed some things about some of the engineering domains, now we'll see about other engineering branches which also evolved with time. Now, we'll see those engineering branches. Okay, right? So, one of those such engineering branches that you could see is you can see this. The earlier, the machine to make flour from the grain. Okay, now it has been replaced with the new machine. Okay, now this is a small one which can be fit into your home, and even the big machines are available. It's just for your reference. Now you can see this in this time zone, that is 1870 to 1960 approximately. So you had lot of improvements, and then you also had electric energy. Remember, when I'm talking about this new electric energy that was available to the masses, so in this time as well, then the steam engines got replaced with you should know that petrol and diesel engines, and the mass transport like trains used diesel engines which were cheaper, till today, right? So now till this era, so there has been a use of IC engines, and also there has been a use of electric energy. But based on the choice, the use and applications are different. But electric energy is considered as clean energy, whereas the other form of energy which use diesel or IC engines in general, so they are polluting, right? So we'll discuss more about it in the future. Okay, right now let us focus on this journey. So the IC engines are were still relevant at this point of time, but along with that, a new source of energy also came into existence, that is the electric energy. So with this electric energy, so some new applications were also built and new possibilities came into existence. If you look at the today's world, so even electric trains, of course, in 1960s India did not have that electrification, but today it's now having a ambition to become 80 or 100% electrified, okay, through all the mass trains, right? So now this is one of the area. Like during this phase, a new domain of engineering came into existence, that is electrical engineering. Okay, now this electrical engineering had its own new trends and demanded new types of knowledge base and also new types of skills, right? So this new type of knowledge base and minimal skills are required for any engineer, and more skills are required for diploma or ITI persons, which are skill based works, right? So here during this period, so that is up to 1960s era, the focus is on electrics, okay, instead of steam or other forms of energy, right? So you can look at the possibilities, like you had pollution less, and then you had good efficiency, and transmission of energy from one place to another place is far easy. So, and you had mass productions, and then good assembly lines and more possibilities, and then wire by logic systems, which in a later part led to some kind of automations. Like at this point, it's simply some small amount of electric logics that were built. So it was all possible in electrical engineering. Now with this improvement in electrical engineering, and then slowly moving towards world wars, right? This is the phase where lot of engineering or R&D of engineering came into existence, and there was huge demand. So during these wars, so engineers played a critical role in developing newer and newer versions of warfare systems, which actually led to a lot of improvement in engineering knowledge base, and thereby new engineering branches came into existence. So in these two world wars, okay, so a lot of engineering came into existence. One of the such important engineering that you can see is about electronics, right? So you need to have a precise movement of many of the things. So because of that requirement, I think precision engineering became very important, and that's why the control aspects were important. But along with these controls, the actual movement has to happen from a signal, and that is electronics, right? And it can compute faster. So a lot of electronics came into existence in the early phase. Anyway, it was big, as big as, even bigger than this room, but currently it is even smaller than my hair. So in one hair I can have thousands or millions of transistors can be placed. That is the improvement that we have seen. Because these improvements, I think electronics took a lot of steps ahead. So from analog electronics it have become digital electronics, and now one of the applications of digital electronics you can see in your TV. So all digital gadgets are available, right? The broadcasting happens through digital boxes, right? So now this is basically because of the semiconductor revolution, which till today India has not been part. Yes, the last week itself, Government of India had put forward a plan to start a semiconductor industry in India, right? So now this led to a lot of use of electronics, and then reliability in electronics and use of electronics in various applications, including critical applications like in aircraft, okay, which needs to be tested and validated for longer duration, right? So all these came into existence. So electronics development actually happened, in a rapid phase, but not much in India at this point of time, right? So now in engineering from Indian perspective so far, so Indians are known for designing, because they can only work from how it can be manufactured, but not into manufacturing, right? So till today Indians doesn't manufacture ICs, okay, which are used in our day-to-day equipments, okay. All these phones that we talk of, they get assembled in India today through PLI scheme, but anyhow these are not manufactured as such. All the parts are manufactured from elsewhere and brought into India, and then they are assembled. Anyway, it's a good beginning to start with. So it creates a lot of jobs actually. So this is a skill based, so engineers will not play a role, but as to set up the manufacturing unit, some amount of engineering goes into it, and that's where the jobs are created for engineers, right? And now this actually reduced a lot of computational requirement and also created possibility of huge computational capabilities. So that led to small computers to today's laptops, which are even capable of earlier older versions of supercomputers, right? So old versions of supercomputers are today's your laptops. Now today's your mobiles. So these mobiles are having a high configuration as high as earlier supercomputers, right? So this improvement, okay, led to a new possibility, that is software or IT. So this development led to a new form of engineering that we talk today of a lot of job creativity in India, that is computer science and also information science, right? So these two branches, computer science and information science, are possible only because of high capabilities of high computational capability that were possible due to hardware existence. So now today we have a lot of jobs actually. So these jobs are going to grow, and we are, as Indians, we will have a lot of jobs in coming days from this sector, computer science and information science, right? So this is going to be even more, right? Already we are, far off. We have taken a big leap from 1990s till today, right? So we are going to be there in the top racers for these jobs. So this is going to continue, right? So now India became a hub after 1990s, right? So what we saw so far is we had a semiconductor revolution that led to information revolution. Now, because of this information revolution and semiconductor revolution, and again further improvement of semiconductor for higher powers, we have high power motor control applications. Now what you see today, of course I'm going to discuss about this in some other video. So the electric vehicles, so that is because of the possibility of controlling the high power, right? So of electric vehicles. So this is one of the reasons that this is going to be interesting, right? So now with the improvements, as we saw that we had many engineering domains like electrical to electronics, and then computer science, and then information science. Remember the electronics that we discussed, they were also applied for various applications. So for example, for communication perspective. So some of the branches can be called with permutation combination like electrical and electronics, electrical and computer science in some areas, then electronics and communications, even particularly limiting electronics and telecommunication, and then even you can have some branches like instrumentation, because you can apply for manufacturing or designing a new instruments. So even that knowledge of electronics and mechanical are going to be useful in designing the instruments. So right, so instrumentation engineering is also going to be a possible other branch. Okay, so now with this lot of knowledge, okay, so industry revolution that happened, that we just talked of, so it gave us a lot of knowledge base, and also it gave a new branch that we are going to discuss now. So that is mechatronics. So I think we'll discuss more about this branch in the next video. Thank you.
If you like this video, kindly click the like button below. Subscribe to this channel for updates on this and similar topic, and share the video with your family and friends. Kindly suggest the topic of your interest to be covered in the next videos, and also your point of view about this video in the comment section below.